A lot of stuff has changed since launch, so we're looking at an updated test of the 5070 Ti versus the 9070 XT in 2026. I have the Asus Prime 5070 Ti here, and I have the ASRock Monster Hunter Wilds Edition 9070 XT. Both of these are running at their out-of-the-box settings. Now, we're going to be looking at some side-by-side footage. We're also going to look at a bunch of graphs, but we also need to think about current pricing, because this is one of the biggest reasons we need an updated advice video, because the 9070 XT, while it's above its MSRP, it's actually still selling pretty close to where it was at launch. Actually, for a while, it was higher than this. And we're at about $690 for the least expensive version, some a little over $700. So I would say $700 is a pretty typical price for the 9070 XT. This is all based on US pricing. I know that worldwide things can be a little bit different. Now, the 5070 Ti, on the other hand, is way above its MSRP. Now, ignore this because I don't know why this is showing up on PC Part Picker, but that's a 9070 GRE. So if we look for an in-stock 5070 Ti, a $900 model is available from Asus here, and it actually is the Prime version I'm testing in this video. They're not usually in stock at this price, though. A much more typical price would be these $980 to $1,000 models. So we're kind of in that $900 to $1,000 price range for 5070 Ti's on the current market. So if we look at a typical pricing of $1,000 versus $700, you're spending about 43% more money if you want to get the 5070 Ti. If you look at the lowest pricing available today in the United States, it'd be $900 versus $690, which is 30% more money for the 5070 Ti. Either way, it's a lot more money for the 5070 Ti, and they are both giving you 16 gigabytes of VRAM, so it really comes down to performance and features between the two brands. Now, if you want to fund your upgrade, I highly recommend checking out Jawa.gg. Huge thanks you to them for sponsoring today's video, and I can even get you $10 off your first purchase using code OWEN10. Now, you can create your own listings, set your own prices, sell your old hardware to fund that upgrade. You can also go the maximum convenience route and click the Get an Instant Offer to get a CPU or GPU instant offer selling directly to Jawa, and it's super quick and easy. Also, I love that you can get entire pre-built systems, and one thing I really like is that you can sort them by price to performance as well as total performance. So you can see that one build might be faster than another one, but once you take the price into account, one might be offering significantly better value for the money. You can also sort performance for specific games, specific monitor resolutions, all sorts of stuff, even themes. So I really like the full pre-built systems available here. There's tons of great user reviews, and please follow the link in the sponsored comment and or video description and check out Jawa today. Now, let's go ahead and get back into the benchmarks. So let's look at the side-by-sides. Now, I chose to focus on newer games. So almost every game I'm testing here is either released in 2026 or is one of the more popular releases of 2025. But I also don't just test out maximum settings. I also test out with upscaling, without upscaling, and sometimes a reduced graphic settings preset, especially if the highest settings aren't getting a super great performance. So at maximum settings with RT set to high, which is the highest you're allowed to set it on AMD cards, more on that in a minute, the 9070 XT is hitting 71 FPS, the 5070 Ti is hitting 73, and that gives the 5070 Ti a 3% advantage. Really, it's about the same. I mean, there's a little more energy efficiency on the 5070 Ti side, which you'll see throughout the testing today. But overall, I think in a blind test, you'd have trouble telling which GPU you'd be using here, and that's going to be the case in a lot of these tests. But what if we kick on DLSS and FSR4 at the balanced preset? Well, now frame rate wise, we're still essentially tied, although it's 113 FPS versus 115, so 2% advantage for the 5070 Ti. And also image quality wise, I really think FSR4 is looking very good here. I think both do look quite good. However, the 5070 Ti does have a feature available here that we're not allowed to turn on non-NVIDIA GPUs. Now, I don't like that that's the case. But it is the case. So here, the 5070 Ti can use path tracing, and you're not allowed to enable that on the other cards. So max settings plus path tracing with DLSS balanced, also using ray reconstruction, you get very playable frame rates. We're over 60 FPS, and this is without using any frame gen. And in a single player title here, I think kicking on some frame gen from this level of base frame rate does look and feel pretty good. So that's just an annoying thing you have to deal with, is some games just block out that feature. Now, another big release of 2026 is Forza Horizon 6 at 1440p extreme settings plus RT, which is the highest graphics preset in the game. The cards are once again basically tied. The 69 FPS for the 9070 XT is pretty nice, but only puts it 1% ahead of the 68 FPS on the 5070 Ti. Both of them looking good here, both of them performing well at native resolution. However, if we kick on DLSS and FSR4 balanced, we're now getting 110 frames per second on the 9070 XT versus 104 frames per second on the 5070 Ti. So it's now a 6% lead for the 9070 XT, so it seems to get a little bit more of a boost out of the upscale here than the NVIDIA GPU did, but we're still in single-digit percentage differences here, so we're not talking a blowout win on either side. Again, the NVIDIA side is still a little more energy efficient. There's some small differences between the upscalers. I do think DLSS has a slight edge there, but both look pretty good, very usable here. Forza Horizon 6 1440p extreme settings. This is without ray tracing now, so it's actually a few notches down on the graphics preset list, but native resolution, it's 127 FPS versus the 121 FPS. And I noticed I put the 5% lead on the wrong GPU. Sorry, typo. I'm going to block that out with my head. So the FPS numbers are correct, and it is a 5% lead. It's just I typed it on the wrong GPU. Sorry. Now, if we kick on DLSS and FSR4 balanced on top of the 1440p extreme settings, so same settings we were looking at before, but we're not native resolution now. It's 149 FPS for the 9070 XT versus 146 on the 5070 Ti, so it's now a 2% lead for the 9070 XT. Again, FSR4 versus DLSS 4 here, they're both looking pretty solid. I think both are very usable upscalers. AMD did a lot of work with FSR4. Now, another big release of 2026, we have Pragmata at 1440p quality, which does include ray tracing, and this is the native resolution. It's just the preset name is called quality. It is a 5% lead for the 9070 XT at 130 FPS versus 124 FPS on the 5070 Ti. So 5% lead. Again, we're talking small single-digit percentages here. It's a win for the 9070 XT, but we're not talking a blowout in either direction here. Now, if we kick on DLSS and FSR4 at the balanced preset, frame rates go up. It's now 162 FPS for the 9070 XT and 158 for the 5070 Ti. So a 3% lead for the 9070 XT. So again, small single-digit percentage win, but not a knockout blow. Image quality-wise, again, there are differences between the FSR and DLSS images. I think both do look very good here and are very usable. Now, if we go to the balanced preset, this is native resolution. It's just the preset name for the graphics is called balanced, and this one does not use ray tracing by default, so I left it off. We're hitting 148 FPS for the 9070 XT, which puts it 1% ahead of the 5070 Ti, which has 146 FPS. So nice high frame rates at native resolution at this graphics preset. And I think some people may want to leave RT off here because it is a bit noisy, unless you could activate path tracing, which we can't do on the AMD GPU. So I can't include it in the benchmark numbers, but it's an experiential difference. The 5070 Ti can use the max settings plus path tracing with DLSS balance and ray reconstruction and get very playable frame rates here, averaging well over 60 FPS, even this more open area, which is more demanding than a lot of the scenes. And I think the graphics look quite good with path tracing in this game. So that's an experiential difference you get. Now, just for the sake of getting a path tracing versus path tracing example, I went ahead and used Cyberpunk, despite it being the oldest game in my testing here, and using DLSS and FSR4 at the balanced preset with RT Overdrive, it's a 46% lead for the 5070 Ti. So perhaps that's why some games leave off the AMD GPUs with the path tracing modes, but it would be nice to have the option. Also, the image just looks better, especially in the reflections on the 5070 Ti because of ray reconstruction. Now, Crimson Desert is a game that has a very high level of ray tracing when you turn on ray regeneration or ray reconstruction, which I'm using here. Kicks on like a hidden higher ray tracing mode. They don't call it path tracing or anything, but it's very, very heavy. Even using DLSS and FSR4 balance, again with ray reconstruction and ray regeneration enabled, the 5070 Ti hits 58 FPS, putting it 14% ahead of the 9070 XT at 51. So this is a very heavy mode. There's also definitely some differences in image quality between ray reconstruction and ray regeneration. Now, if we drop down to the ultra settings with no upscaling, this game still does use ray tracing though. We're at 91 FPS for the 5070 Ti at native resolution versus 81 FPS on the 9070 XT, so it's a 12% lead for the 5070 Ti. Again, this game does always use ray tracing, unless you're on a GPU that just like doesn't support hardware ray tracing, and it does have a software fallback. But this is still using ray tracing here. At 1440p Ultra, but using DLSS and FSR4 balanced, it's now a 5% lead for the 5070 Ti at 112 FPS versus 107. Now, I'll be honest, these GPUs were doing well enough without using upscaling that I'd probably leave it off, as I don't think the foliage looks very good here. If you look at like the grass right now, things like that on either FSR or DLSS. I don't really like the look of upscaling in this game very much, so I'd much rather play it at native resolution. Now, Call of Duty Black Ops 7 released last year, but it's a popular multiplayer title with a built-in benchmark, so we'll use that. And this is a game that definitely still favors AMD GPUs. 1440p balance, this is native resolution, just the balance preset. We're at 243 FPS versus 215, so 13% lead for AMD, although both GPUs are getting you a high enough frame rate that if you don't get the kill, it's a skill issue, not your frame rate, guys. Anyway, it's over 200 FPS, that's enough. Now, 1440p balanced with DLSS and FSR4 balanced, so now we're using balanced upscaling on the balanced preset. The 9070 XT climbs to 255 FPS, the 5070 Ti climbs to 232. There's some signs that we might be starting to see some CPU limitations at times here, but it's still a 10% lead for the 9070 XT. And this game does feature like a heavy ray tracing workload with ray reconstruction, ray regeneration, but I'm not going to test that here because nobody uses that in the multiplayer mode. Now, Battlefield 6 is another big multiplayer release from last year, and at 1440p maximum settings, which are called overkill here at native resolution, it's 114 FPS versus 106. Giving an 8% lead to the 5070 Ti. So while Call of Duty seems to be a little more AMD focused performance-wise, it seems to flip if we look at Battlefield 6. Between the two games, I personally prefer Battlefield 6 pretty heavily, but that's just personal preference. Now, if we go to DLSS and FSR balanced mode, the 5070 Ti is now at a 12% lead. It's 156 FPS versus 139. So definitely a game that seems to be favoring the NVIDIA GPU. However, I don't just test out the maximum settings, especially in multiplayer titles. I think it makes sense to turn down the settings, even though we are getting very good frame rates here, so you certainly could play at these settings. But if we drop down to the medium settings, I actually found it interesting that the GPUs ended up actually averaging 175 on both. So it seems like the overkill settings were NVIDIA favored, but by adjusting the graphics settings, it loses some of that NVIDIA favoredness to the benchmark results. And that's another reason why I test out multiple graphics settings in games, is sometimes it's not just one game or engine favors one GPU brand over another. Sometimes it's actually the specific settings. Now, if we're at the medium settings, but we kick on DLSS and FSR at the balanced upscaling, it's now a slight lead for the 5070 Ti, but down to a 2% lead here, so not like what we were seeing on the overkill settings, but 219 FPS versus 214, and once again, we're well over 200 FPS here, so if you're not getting the kill, definitely your problem, not a hardware problem, guys. Now, of course, you can still try to chase those last couple FPS for any little advantage you can get. Now, Marvel Rivals, another popular multiplier title, and this one has a built-in benchmark, so I thought we'd take a look at it here. 1440p ultra settings, it's 87 FPS versus 85 with a 2% advantage for the 5070 Ti. So again, one of these like small single-digit leads one way or the other. In actual gameplay, you'd struggle to tell the difference. Now, maybe if you kick on upscaling, you'll see some small differences. So testing that out here with DLSS and FSR4 at the balanced preset. Performance-wise, we're now getting a 9% lead for the 5070 Ti, so it seems to benefit a little bit more from the upscale performance-wise here. 124 FPS versus 114. So one of the slightly more noticeable leads that we're seeing in any of the games we're testing here, almost getting into double digits, but both GPUs giving you a good experience for sure. Now this is on the ultra settings, so of course we could just go down to medium settings and even at native resolution now. We're getting 142 FPS on the 5070 Ti, 130 FPS on the 9070 XT, so 9% lead for the 5070 Ti again. So Marvel Rivals seeming to be a little more on the NVIDIA favored side of things. So this is one of those things where game by game, we can sometimes see advantages swing either way. We're rarely much over like a 10% difference, but if you spend most of your time playing one particular multiplayer game, you might take that into account in your purchasing decision. Now, Subnautica 2 is a very popular release, even though it's technically still just early access. Lots of players, so 1440p medium settings, 114 FPS versus 101, so now we're seeing one of the bigger leads we've seen for the 9070 XT with a 13% advantage here. So again, just something to keep in mind. In specific games, sometimes it's a little more favored one way or the other, both getting a good experience at the medium settings here. If you kick on DLSS though, you can't kick on FSR. So maybe by full release, they'll have FSR support, but when early access launched, we just had TSR from Unreal Engine 5 upscaling, and it looks okay, but setting it to the same internal rendering resolution, the 9070 XT still has a 12% lead here at 162 versus 145. But again, it'd be nice to have FSR4 support in the game, and we don't have it. Now, you can always use things like Optiscaler or something like that to try to hijack the DLSS pathway and get some FSR4 in there, but it's annoying to have to do that. Now, at epic settings, frame rates are a lot harder to handle here. We're seeing 63 FPS versus 57, so these GPUs are strong enough for around 60 FPS. The 9070 XT is 11% faster. So Subnautica 2 seems to be AMD favored performance-wise, but feature set-wise with DLSS, kind of advantage goes to NVIDIA there. So that's where you have to kind of weigh those feature advantages. Now, the most popular title of last year is well, maybe not most popular, but the most well-reviewed, lots of Game of the Year awards and all that, I guess I should say, is Clair Obscur Expedition 33. 1440p max settings is about a tie, 60 FPS versus 59, but 2% advantage for the 9070 XT technically here. So another one of these very small advantages one way. Now, if we kick on DLSS and FSR4 balanced, you can take a look at the image quality differences. And, I do think there's a small edge in the little leaves and things if I look really carefully for DLSS here, but both are looking very usable. It's 94 FPS versus 90, so 4% lead for the 9070 XT. So again, one of those small single-digit percentage wins. But hey, it's something. Now, if we go down to the medium settings, instead of using the epic settings with upscaling, we're able to stay around 100 FPS. It's 100 FPS on the 9070 XT versus 99 on the 5070 Ti. Both of these are using native resolution here, so both getting a nice high frame rate. Again, the medium settings still look pretty good rather than using epic settings plus upscaling, so you can kind of take your pick over whether you prefer reduced settings with native resolution or not. If you really want to chase frame rates, you could use the medium settings plus upscaling. Here we're looking at DLSS and FSR4 balanced on the medium preset, and it's 140 FPS for the 9070 XT versus 136 FPS on the 5070 Ti, giving a 3% advantage to the 9070 XT. So again, this is one of those games where there is an advantage one way, but it's one of those small single-digit percentage wins, which seems to be a pretty typical result. Now, that's all the updated benchmarks I ran here for the newer releases of 2026 and some of the more popular games of 2025. And so how can we summarize all of it? Well, I just noticed how sparkly my shirt is. I guess this is a green enough shirt that it's interacting interestingly with my green screen. I remember I do use a green screen here. So anyway, there's that. So anyway, if we look at all of the tests, the average FPS, 5070 Ti in green and 9070 XT representing Team Red here in red, what do we make of it? Well, again, it's kind of hard to look at graphs like this, I think, and get much out of it. That's one reason why I really like the side-by-side breakdowns, to get a better feel for each game and the different settings, what they look like, the upscaling available, all of that. Also remember that, like the path tracing mode, I showed that there's some games where you can do that on the 5070 Ti and you just don't even have the option, so it doesn't show up here in the graphs like this on the AMD GPU. Now, I think that if you're going to look at it as a graph, though, this style of graph is a little bit more useful for comparing the two. So this is showing every test again, but instead of saying the average FPS, it's showing the percentage advantage or percentage deficit. In this case, I'm doing it as the 9070 XT. When it's ahead, I'm giving it the positive value. And when it has a deficit, I'm giving that the negative value. So here you can see that really it's basically a tie overall. Overall, it's a 5070 Ti rounds up to a 1% advantage of all of the tests. And so, yeah, there's not a lot to it. You can see that in many games, one GPU or the other is a small single-digit percentage lead. And in other games, it can expand out to a 10% or so lead, but it can be either the AMD GPU or the NVIDIA GPU getting that lead. It just really depends on the title. So if you have one specific game that you're going to spend most of your time in, you might try to factor that in a little bit more heavily. But on average, these GPUs come out about the same. Now, the biggest difference we see, though, is in path tracing. So the one game that supported both GPUs in path tracing that I tested here was Cyberpunk, and there was a huge advantage for the 5070 Ti there in performance, which we're seeing here, but also in image quality. When you look at the side-by-side footage, especially in puddles and things like that, ray reconstruction was putting in a lot of work. And then there's the stuff that doesn't show up in these charts, where in Resident Evil Requiem and Pragmata, both of which look quite good with the path tracing modes, well, you can't enable that on the on the AMD GPU, which I don't like. I hate that decision from developers. I hope there's no pressure from NVIDIA doing that behind the scenes. It'd be nice to at least have the option to turn on path tracing for AMD, or Intel for that matter. You just can't do it if it's not an NVIDIA GPU. So I'd love to have that option, but the 5070 Ti has the option, AMD doesn't, and even if I don't like that that's the case, that is the case, and it's fast enough to get a playable result. Whether you choose to use those settings or not, it is usable with balance level upscaling, and then you could choose whether or not to use frame gen from there. So those are things that don't really show up in the charts like this. Now, speaking of ray tracing, I know some people like it to be separated out in the benchmarks. So if I separate this to ray tracing only, then this is what it looks like. Again, green is NVIDIA, red for AMD. And again, I really think that just FPS charts like this aren't the best way to process this information. So if instead we look at this again, this is the ray tracing only results, and I'm including path tracing as a type of ray tracing. So here we're seeing that the 5070 Ti comes out on average 6% faster. And that's using the geo mean, which is pretty resistant to outliers compared to an arithmetic mean, so that helps control for the big path tracing thing. But remember, the path tracing modes where the 5070 Ti can use it, but AMD can't, they're not factored into this because it's not like a number that I can factor into a geo mean. Anyway, so yeah, the advantage is a little bit more heavy in ray tracing, but AMD keeps up pretty well in the normal ray tracing workloads. It's really just in the path tracing workloads that we see that much being set apart. Now, if on the other hand, you'd rather just look at no ray tracing at all, here's what that looks like. So if I separate this out for no ray tracing, there's the average FPS in each of the tests. And if we instead look at the percentage differential, it looks like this. So you can still see some swings either way, but at least in the selection of games that I tested in this video, AMD now comes ahead by 2%. So if we average all of the tests, NVIDIA has a 1% advantage. If I get rid of all the ray tracing, AMD has a 2% advantage. If I focus only on ray tracing, NVIDIA has a 5% advantage, or was it 6%? I already forgot. 6% advantage. So overall, really, I don't think the raw performance difference is the best way to separate out these two GPUs. From a raw performance standpoint, in the vast majority of situations, at least on average, you can have about the same experience. In specific games, you will see a wider difference between the two, so that is worth looking into if you spend a lot of your time in one particular game. Really, I think it's the price and then the feature set differences that would really distinguish these two GPUs, since their overall performance is about the same on average and they have the same amount of VRAM. So that's where we get back into the pricing differences. So like I said, a typical price for the 5070 Ti is about $1,000. A typical price for the 9070 XT, again, these are United States pricing, is about $700. So you'd be spending about 43% more money typically on a 5070 Ti for basically the same performance except for in path tracing. Now, if I look at the lowest price models available today as of the time of filming in the United States, it's $900 versus $690, making it only 30% more money for the 5070 Ti. So that is a lot more money to spend for basically getting a better path tracing experience, or sometimes just getting access to path tracing when you otherwise wouldn't have access to it. So yeah, that's a lot more money. Now, path tracing is not the only difference. We did see some games like Subnautica 2 where DLSS is available and FSR isn't, and that's not the only game like that. So there are other advantages to that NVIDIA ecosystem, DLSS having more wide support, the image quality being a little bit better. I wasn't testing out frame generation in this video, but NVIDIA's frame generation does have smoother frame pacing. It also has more options for multipliers for how far you want to push it. It has a dynamic mode. If you get into productivity workloads, there's a lot of times better software support for NVIDIA and things like that. So I don't want to act that there's nothing you're getting for the extra 43% or maybe 30% more money that you're spending on the 5070 Ti, but that is a lot more money. So they're really in very different price classes. So I would kind of break it down like this. If you're looking for the most powerful GPU that doesn't start having extremely diminishing returns on its price to performance, I think the 9070 XT is that. You start to pass the 9070 XT, you start spending a lot more money without getting much more for it. So I think from a value perspective, the 9070 XT is just a far better value for gaming. However, if you are somebody who is either upgrading your GPU specifically or building a gaming PC, and you have $1,000 to spend, and you're just wondering, am I getting anything for that? You should understand that you're not getting much more in the way of typical performance, but you are getting, access to path tracing if that's something that interests you, and you're getting the NVIDIA feature set, which is a little bit better, the NVIDIA ecosystem, which is a little better. You're paying a lot for it. It's certainly diminishing returns. So I would say that if you're doing a full PC build, I would certainly look at, could that extra $300 be spent on something else that gets you a more noticeable performance advantage? So for example, are you cheaping out on your CPU to get this $1,000 GPU? Because it might be better to get like a 7800X3D or something like that, instead of doing this GPU, spending the extra $300 on the faster, or better feature set GPU. So yeah, if you're looking at this as part of a bigger PC build, I would look at what else in the build could you do with that $300. Now, if you've already pretty much maxed out the rest of the build, you're at least at like a 7800X3D CPU, and like you've got 32 gigabytes of RAM, you've got a big SSD to fit lots of games on, you've got good cooling so everything will be nice and quiet. So if all of the important things are taken care of, and you still have an additional $300 in your budget beyond what the 9070 XT puts you at, yeah, you're getting something more for the 5070 Ti. I would rather have a 5070 Ti than the 9070 XT, all other things being equal. But they're not, because it does cost a lot more money. So if you have it in your budget, you get something for it. And AMD doesn't offer anything beyond the 9070 XT. So you can't look at the comparison beyond that point. So I don't think it's dumb to buy a 5070 Ti as part of a gaming PC if you have the budget to do it and you've already intelligently budgeted out money for everything else. Because you are getting a slightly better GPU with slightly better support for certain things and all that. So AMD's offering far better value here. But if the money's there, you get something more for it. I think that's the best way to summarize this. And on average, they get roughly the same performance. It's really those specific use cases, path tracing, games that have more DLSS support, things like that. All right, hopefully you guys found the updated look at the 9070 XT versus the 5070 Ti useful and or interesting. And don't forget, you can check out jawa.gg for some great deals, and you can fund your upgrade by selling your old parts here. Again, you can look at the full systems, individual parts as well. Definitely check out the used market. And don't forget that I can get you $10 off your first purchase using code ON10, and check that sponsor link in the pinned comment and or video description.